Before we move into the Etherchannel negotiation protocol discussion, I did want to show you what happens when that channel that went down at the end of the last video comes back up. So all I did was a no shut on that interface that we had shut down and ran show spanning VLAN 1 just a few seconds later, and you can see the cost had already gone down, back down I should say, to 9. So we don't have to do anything else when a link is down like that for it to rejoin the Ether channel, because the configuration still had it in there. Once we repair the problem, then the link will rejoin the Ether channel, no problem at all. Now, speaking of joining Ether channels and whatnot, let's talk about negotiating an Ether channel, because we're going to go into the nuts and bolts of an Ether channel here in the next couple of videos. The industry standard is the Link Aggregation Control Protocol, LACP, and the Cisco proprietary option is the Port Aggregation Protocol, PAGP. The only thing I hate about PAGP is how hard it is to type the small g. It's really quite difficult actually, even after a while. But one thing I love about PAGP, man, it's how the protocol dynamically changes all the other ports in an Ether channel when you change a property on one of them statically, like the speed or the duplex. Now, defined in 802.3 AD, that's a standard, not a year, LACP assigns a priority value to each port with Ether channel capability. And the great thing here is you can assign up to 16 ports to an LACP negotiated Ether channel, but only the 8 ports with the lowest port priority will actually be part of the Ether channel. That's 16 ports per side. That's a really good deal. And the remaining ports will only be bundled if one of the already bundled ports fails. Now we're going to take the Ether channel off that we had built and then rebuild them using the negotiation protocols. So you get to see how they get torn down as well. Let's go ahead and do that. Of course, it's pretty simple. I'm not going to make it sound like it's really difficult. Range fast 021 through 23. And we had the channel group command already in there way back when. There we go. I'm just going to do a Control A and type no. Then I'll go over to 6 and do the same thing. And I'll just type it in real quick. Let's do a quick show config. And you can see the port channel 5 is still in the config. So if you're cleaning up an Ether channel, you need to go delete that port channel as well before you start another lab. Because just taking the channel group off will not get rid of that representation. So let's go ahead and do a no interface port channel 1. And that should do it as far as our config goes. It's all gone from the top. There's no channel group command here. Everything's just trunking. I usually do this when you're not looking, so to speak, but I wanted you to see it this time. So that port channel is gone. So when you're in the lab working with Ether channels, once you take that channel group command off, if you really want to start from scratch, make sure to manually remove that port channel interface as well. And we are ready to go. So this time on switch 2, we're going to go with PAGP first. And I'm going to go ahead and put all of the channels, all the available links in the Ether channel this time. And that's where our number goes. Then mode. And I'm not saying I have any inside information here, but anytime there are 2 protocols that do pretty much the same thing, one's an industry standard, one's Cisco proprietary, one uses active and passive, and the other uses auto and desirable, I would know which ones use which. It's for the exam. It's just a hunch. I would know that. So here, if we're going to use PAGP, we need to either put in the words auto, enable PAGP only if one is detected, or to enable it unconditionally with desirable. So I'm sure you already know the deal here, but I'll mention it anyway. If both sides of a link or an Ether channel, if they're all set to auto on both sides, we're never going to get anything. At least one of those sides has to be set desirable, one of them. So we'll go ahead and do both here, and I'll just enter DES right there. And there's the create a port channel message we saw before. '24 channel group. 5 mode desirable. Creating your port channel again. Lots of line protocols flying up and down, and see they're really flying up and down this time. And I wanted you to see that because, you know, of course, books tend to leave that kind of thing out. But when you see it, now you won't, you know, have any reason to panic. It's the first time you type that in, and all of a sudden you see 10 console messages. I don't care who you are. The first time you see that, it's like, okay, what just happened here? But it looked like everything came up, and what we really like is at the very bottom where it says interface port channel 5, change state to up. So there's our VLAN 1's change state to up. That, of course, interface VLAN 1, our management interface. And I think we're done cooking here. So let's run show PAGP neighbor. Now the show PAGP neighbor command and the show LACP neighbor command, they're going to give you different information. And this is not something where you've got to know everything going on here. You see the partner flags are set to S and C for a slow hello and inconsistent state. We're not really concerned about that right now with the partner flags, that kind of thing. And we've got group cap out there. We're just going to leave that alone. But you can see to start your troubleshooting or your verification, you know, here are your channel group 5 neighbors. Here's the local port that they're on. Here's the partner name. Here's the partner ID, device ID, which of course is the same for all 4 since it's the same partner, and then the partner port. I really like these because this helps with a little bit of verification and also with troubleshooting. It's great basic information to have. It's almost like show CDP neighbor for Etherchannels. I really like that. So that's really it as far as the show command goes. Well, we've got some Etherchannel commands I'm going to show you here after the next lab. And what we'll do now is get rid of PAGP, and I want to show you show LACP neighbor. And to do that, we got to have an LACP created Etherchannel. So let's take that last one off. Tell you interface range, yeah, you know what I'm going to say. It's a trip to get used to it at first. I know it's easier not to use it at first or not to learn it, but man, does it save you a lot of time. Desirable. And you're going to see all kinds of line protocols fly around. I'm going to take that port channel off too. Don't have to, but I'm going to. When I go from one lab to another like this, I really like to start from scratch as much as I possibly can. And we go down and we see the port channel's gone. I've got all my static in cap and trunk commands still. Everything's good there. And we'll go over to switch 2 and just make sure that port channel interface is gone, and it is. And everything is beautiful. Now let's make one with PAGP. And our PAGP choices are auto and, LACP. That's what I meant. Active. LACP is active. That means it's enabling LACP unconditionally. And then passive, enabling LACP only if one is detected. So again, if everybody's passive, nothing's getting done. So at least one side has to be an active. And we will go here with active on both. Oops, interface range fast. And we'll just wait for it to stop cooking, so to speak. Line protocols went down. You see 4 of them come back up. And then let's wait a second here. I just want to make sure all the messages are done. You know, as soon as I start typing, one will come up. CP neighbor. Now this is show LACP neighbor. You can see the information is different, and as far as the things go about admin key, operator key, port number, There's that VLAN 1 message. I was just waiting for that. We're not really concerned about those. Some good information here, though, as far as the ports involved, their priority, in case you've got a priority question with LACP, and the device ID. So I just want to show you those two fields. They're quite different as far as the output goes, but some good fundamental troubleshooting and verification information there. Speaking of that kind of thing, let me show you a couple of my favorite Etherchannel commands. We actually get to type Etherchannels. I'm sure you noticed, we built 3 different Etherchannels now. You're building all these and you're verifying them, and you hardly ever type the word Etherchannel. But you are going to do it now. And show Etherchannel brief is one of my favorites, but I thought I would share this message with you that I got on this particular switch. Command accepted but obsolete, unreleased, or unsupported. See documentation. Oh yeah? Well, the jerk store called and they're running out of you. Man, I can't believe a switch would insult me after everything I've done to this company. But seriously, this does happen on rare occasion, especially the longer you've been using certain commands. And it is nice that they at least give you some kind of warning, says, hey, you might not see this one in the future, because you can type in a show or a view command or a debug that you've been using for over a decade, and then all of a sudden it doesn't work. So Cisco usually gives you some kind of warning. It doesn't mean you've broken anything. It's just saying, yeah, we're going to let you use this, but it's obsolete. But it still gives you some good information. It does tell you what group number you've got, which is 5 here. Group state equals L2. We've got 4 ports, and we've got 1 port channel, and we've got the protocol LACP running. And you'll notice it says max ports equals 16. Remember, LACP allows us to do that. We can name up to 16 ports, but only up to 8 will actually be active. And what's going on with that group state equals L2? This is a layer 2 ether channel. You can actually create layer 3 ether channels for routing purposes, of course, and give them IP addresses, that kind of thing. We're not going to do that right here, but I want you to know why it says group state equals L2, because it would be easy to say, well, aren't they all L2? Actually, they're not. Let me run another one here. Show Etherchannel summary. That one's not obsolete. It's got some flags here, and we don't need to know what every single one of them means, but a couple of them are great. P, bundled in port channel. That sounds pretty good, and you'll notice that that's what all of our ports down here are. What I like about this command, it doesn't just tell you how many ports you have in a particular Etherchannel, it tells you which ones they are and what their statuses are. And just going from left to right here, group 5, we know that part. Port channel PO5, and then it has an S and a U in uppercase. And all we got to do is look up in our table here to see that uppercase S is layer 2 and U in use. We like that. Protocol is LACP, and then there are all of your ports. So it's a fantastic thing. It's a great command to do a little verification, do a little troubleshooting with. So now we've seen how to fully remove an ether channel, especially helpful in a lab environment, and make sure to get rid of that port channel when you do that. And we saw the verification commands for PAGP and LACP, the show neighbor commands, that is. Now, what we're going to do in the next video is talk a little bit about how the load is distributed over the ether channel. There is a slight bit of math involved, so you might want to grab something to write with. We're going to do a little bit of binary conversion, not a whole lot, but it's important stuff, and it gives you a good idea of exactly what's going on the ether channel and how to change how the load is distributed if you need to do that. So we will chat about that on the very next video.